Greetings to all of you. In this session, we are going to discuss about intermediate chemistry on international floor. If you are preparing for any entrance exam or competitive exams as well, national level JEE Advanced and JEE Mains Chemistry for NITs and IIT entrance. In addition, NEET Chemistry for medical entrance examination, Telangana EAMCET and Andhra Pradesh EAMCET for engineering entrance examination. In addition to all these, if you are preparing for any kind of competitive exam conducted by the government streams, so this kind of session will be very much helpful. Let's enter into our today's session. First question is given from IUPAC nomenclature. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry, right? So as per the IUPAC, there are two compounds are provided. One is, in general, we can say it is called formamide, and second is called acetamide. This is general terminology. As per IUPAC protocol, we need to assign perfect naming, systematic naming to these two compounds. Let's see how can we name them. Here, HCONH2, this is also the kind of acid derivative derived from the carboxylic acid, right? So here, one of the carbon will be there, so that we have to go with methane. One carbon compound is taken as alkane terminology, it can be taken as methane. As per the IUPAC nomenclature, being it is amide, it can be pronounced as a alkanamide. Alkanamide is the general name, being it is one carbon organic amide, so that we can say it is a methanamide. For this kind of compound being one carbon, we have to pronounce as a methanamine. And the second compound CH3C double bond O NH2 is given, where alkane terminology will be ethane, being two carbons are accompanied with this compound, right? And it can be named as the entire name as per the IUPAC nomenclature. It is given as the ethanamide. Two carbons can be pronounced as eth and alkanamide, so that we can say ethanamide. This is the way we can answer. Then as per the IUPAC rules and regulations, amide if present in the given compound, we have to go with alkane, E can be terminated and amide can be added. Simply we can pronounce alkanamide. CONH2 is the general formula for amide, and it can be pronounced as a alkanamide. IUPAC name of this compound is given like this. Okay, so that IUPAC protocol, this is said to be a methanamine, and second one is called a ethanamine. This is the way we can answer question number 1. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Draw a circle. Here orange juice is provided. Everybody aware orange juice is of acidic, being it is souring taste, whatever. Most of the acidic compounds are souring in nature, so that we can say orange juice is acidic in nature, right? So draw a circle around the pH of orange juice, right? So orange juice pH, these many are provided. We need to identify which is suitable. So very simple to identify, because among 4 options provided, only one is acidic pH, remaining 3 are basic pH only, no? So that we can simply identify, because 7 pH is neutral in nature, pH 10 means a basic, pH 13 means a still stronger base. So that it is very simple to identify the right answer from this one, because they only gave the hint orange juice is acidic in nature, and among the options only acidic pH is only 1, so that it is very obvious to give the answer 1. So let's see the detailed explanation over here. For this kind of question, any kind of natural compounds are provided daily. We are consuming so many type of compounds. We can rate them on this pH scale. pH is the system which used to identify the nature according to the grading on the system, on the scale. Fine. The numbering starts with 1 and ends at 14. 1 to 14 will be there. Based on this kind of scale, this kind of grading, we can assign less than 7. All the compounds are said to be acidic. And if we are ascending towards 14 from 7, so that we can say basic in nature. Okay, if we are moving towards the left hand side, acidic strength gradually increases. If we are ascending towards 14, basic strength increases. Okay, these arrows rightly represented, where in between 7 is indicated for neutral nature, right? So our gastric juice, as everybody aware, in our stomach we are secreting hydrochloric acid whose pH is said to be 1. Okay, lemon juice pH is said to be 2. Apple juice is having 3, and here we have tomato juice, 4 pH will be there. Black coffee contains 5 pH. Milk pH will be 6. Pure water pH will be 7. Neither acidic nor basic, we can say it is neutral. Egg is slightly basic with 8 pH, and baking soda is of 9 pH. 10 pH is given for hand soap. Okay, so it's very simple to understand that whatever cleansing agents we are using at home for floor cleaning, cloth cleaning, or else glass cleaning, any type of furniture, whatever the kind of things we are using, generally they are basic in nature. Whatever we are consuming as the food materials are acidic in nature. From this table only we can clearly analyze. If you see, pH 9 is baking soda. It also used in washing purpose. Hand soap, that is whatever we are using as a hand wash, that can be accompanied with the pH 10. Ammonia solution, which is used to clean the floor, no. Bleach, this is also used to remove the stains, so that pH 12 can be assigned. And this is of the solution, concentrated solution of alkali. Concentrated alkali solution if taken, that is 13-14 will be there. This is the way we can assign all daily ingredients, whatever we are using at home daily, according to the pH scale. pH grading is provided. Acidic is indicated left hand side, basic is given in right hand side, in between neutral will be there. Among all this, orange juice pH exactly identified as a 3.5, which is acidic in nature, right? So from this question number 2, you can clearly answer pH 4 is the nearby. 3.5 is not provided, so that we can round up, and that value is taken as pH 4. And one more question is also there. Some soils are acidic. This is most important regarding the agricultural field, agricultural cropping purpose. We can focus on this kind of question. Some soils are acidic in nature. Give the name of 2 compounds that are used to make soils less acidic. Why we have to make less acidic? Any soil, that nature of soil mainly depends upon what minerals are located inside, right? Based on that soil texture, soil component, soil nature will be assigned, right? Some soils are alkaline in nature, some are acidic in nature, some are neutral in nature. That depends upon type of composition it is having, right? So if the soil is having acidic nature, what is the remedy to treat it, and how can we neutralize that type of soil? In order to make neutralize, being it is acidic, very obvious to add any base. Here you are adding calcium carbonate or else sodium bicarbonate. They are asking for 2 compounds. I am taking one of the compound as lime. Lime is naturally occurring compound, no? So that calcium carbonate, whenever calcium carbonate is added to the acidic soil, so that we can neutralize. Neutralization is possible, and carbon dioxide will be evolved, and water that is absorbed, percolated into the soil. Another one is, if soil is added with sodium bicarbonate, what happens? Sodium will be neutralized, will neutralize the soil, so that sodium ions will be attached to the soil, and leftover will be water and carbon dioxide. Whatever released here, that remains same. If you observe, you can see the bubbles over the soil surface, the bubbles regarding this carbon dioxide gas, whichever evolving. This is the way we can neutralize the soil if it is acidic in nature, right? So this is another question. Why we need to do this? If soil is too acidic, that is not suitable for cropping in the agricultural fields. That's the reason why soil testing is required. If it finds acidic, so that we have to neutralize in certain ways. Either baking soda stand for what? Sodium bicarbonate, and you can mix the baking soda with the soil, or else calcium carbonate. Lime is also naturally occurring substance, so that we can neutralize. This is the way we can go for the treatment of the soil if it is find defective. Fine. So this is the answer for question number 2. Move on to question number 3. The electrochemical extraction of aluminium from the bauxite ore involves. This is the question collected from JEE Advanced Question Paper 2021, and it is the question came from metallurgical process. Electrochemical extraction of aluminium from bauxite ore involves. Being it is the extraction process of aluminium. Aluminium is the lightweight metal, no? So that can be extracted from the most common ore called bauxite. Bauxite is the oxide ore of aluminium. And we are applying the process is called electrochemical extraction. What is meant by electrochemical extraction? We are subjecting that kind of entire process under electrical condition, right? By applying the electrical current, there is a provision for the chemical reactions in order to separate all the impurities from the aluminium ore. So during this process, the reaction of alumina with coke at temperature is greater than 2500 degrees centigrade, they are saying, but it is not correct. The neutralization of aluminate solution by passing carbon dioxide gas to precipitate hydrated alumina. So aluminate solution, if there, aluminate generally exists in the form of sodium aluminate. For example, the sodium aluminate, if treated with carbon dioxide, what happens? That will be turned into hydrated alumina solution. And the next is about the dissolution of alumina in hot aqueous sodium hydroxide. It is possible because everybody aware that alumina is a kind of acidic oxide. Alumina is a kind of amphoteric actually. Amphoteric denotes what? It contains a both the nature, dual nature will be there. So certain extent of acidic nature, certain extent of basic nature, both are there for alumina, so that whenever it is treated with sodium hydroxide, it will react because certain acidic nature is there, right? That's why it will react with sodium hydroxide. This will be correct answer only. The electrolysis of alumina mixed with the sodium aluminium fluoride. This is called what? Cryolite, right? Cryolite to give aluminium and carbon dioxide. Okay. So this is also correct answer. We will see how can we explain all these. Why first answer is incorrect, we will discuss. Okay. Alumina will, when reacted with coke, we have to maintain the temperature 2500 degrees centigrade, they are saying. But it is not true. We need to maintain the temperature 1700 to 2200 Kelvin. They are saying centigrade. So Kelvin scale, they are mentioning 1700 to 2200 sufficient. Okay. So that's the reason why this is not correct. So 2500 means on Kelvin scale, it is not exactly in the range of this 1700 to 2200. I think everybody aware that how to convert centigrade into Kelvin. So whenever the value is there, if it is added with 275, that centigrade units, if added with 273, so that it will be converted into Kelvin scale. So if we are adding with 273, further the value will be increased, not laying in the range of 1700 to 22. So that we can't say this is the correct one. So this is a wrong answer. Move on to option number B. Option number B, aluminate. If you are seeing here, aluminate means what? Sodium aluminate we are taking. Okay, so here we can see here sodium aluminate can be treated with carbon dioxide. Being it is the sodium salt, carbon dioxide if added, what happens? Alumina will be released, and there is a formation of sodium carbonate. Sodium carbonate can be removed. This will be precipitated. That is the way you can clearly see. Here sodium aluminate we are taking treated with carbon dioxide. Alumina solid, precipitation is possible, and sodium bicarbonate is another byproduct you can clearly locate, right? This is the way we can we can say option number B. Move on to option number C. The dissolution of alumina in a hard aqueous sodium hydroxide that we already discussed. Option number 4, electrolysis of alumina mixed with a sodium aluminium fluoride called cryolite to give aluminium and carbon dioxide. Let's see how it is possible. Okay, so here you can clearly see whenever this is called cryolite Na3AlF6, this will be electrolyzed to fragment into sodium fluoride, aluminium fluoride. Aluminium fluoride further fragmented into aluminium trication and fluoride anion will be generated. At a cathode, aluminium cation will accept the electron so that aluminium metal will be generated under liquid condition. And whatever fluoride is there can release the electron and fluorine will be generated. Whatever alumina is there, Al2O3 is there within the reaction, being it is the bauxite, so that oxide of aluminium will be there, treated with carbon so that aluminium and carbon dioxide will be evolved. This is the way we can explain about alumina can be mixed with cryolite to give aluminium and carbon dioxide. Aluminium released, we can see aluminium released and carbon dioxide also evolved. So that this is the way we can give the answer for the question. B will be correct, C will be correct, D also correct. First one, that will be ranges from 1700 to 2200 Kelvin. So for question number 3, option number B, C, D are correct answers. Move on to question number 4. Question number 4 is given from organic chemistry. Starting, we are taking propionic acid. 3-carbon carboxylic acid is called what? Propionic acid. If we are treating with the bromine under red phosphorus condition followed by hydrolysis we are doing, this is very selective reagent. Bromine red phosphorus is selective for alpha bromination. With respect to carboxylic acid, the second carbon is alpha and alpha bromination is possible. That will be the product P. That means a 2-bromo-propionic acid will be generated. Now we are treating with potassium thalamide. We can say this is potassium thalamide, subsequently treated with alkaline solution NaOH and hydrolysis carried. One of the product is phthalic acid. What else we will get as a Q? So that to be identified. Okay, Q is P to be determined, Q to be determined. If you write the reaction series so that we can identify what is P, what is Q. And from this data, we have to answer P can be reduced to primary alcohol using sodium borohydride. Sodium borohydride is the reducing agent. Whatever P compound is there, if treated with the sodium borohydride, you will get primary alcohol. Yes or no, we don't know. We have to check it out. Treating P with a concentrated ammonium hydroxide solution followed by acidification gives a Q. Okay, there is another way. We are going with bypass route so that ammonium hydroxide will be treated to the P. So and acidification is carried, and in that route also you will get a Q. Let's see whether it is possible or not. Treating Q with a solution of sodium nitrate, aqueous HCl liberated nitrogen. Okay, this is the kind of reaction where you can generate NaNO2HCl. Nitrous acid will be generated. That nitrous acid will be treated so that we will get nitrogen. This is the correct answer only. We will check what kind of options, whichever provided, are correct with respect to this organic chemical reaction. Okay, so here another option is also there. P is more acidic than propionic acid. So whether it is correct or not, we have to check out. So P is more acidic or less acidic, that also we have to explain. Okay, from these many options A, B, C, D, the correct answers will be B, C, D. Why can't we say A option is wrong? A option, why can't we say A option is correct? Okay, P can be reduced to primary alcohol using sodium borohydride. So in order to get that, first of all, we have to identify what is P, what is Q. Okay. Initially, propionic acid was taken, bromine red phosphorus, subsequent hydrolysis was carried. Okay, whenever this is possible, bromo will be attached at second carbon. We will get a 2-bromo-propionic acid. This is called alpha bromo propionic acid, which will be P. This will be further treated with potassium thalamide and hydrolysis. That is the kind of reaction where we can get alpha amino acid. This is called alpha amino acid, namely alanine. Alanine is the amino acid which is most important in the protein synthesis, right? This will be Q. Q is the alanine. P is the 2-bromopropionic acid. Now we have to go for Y. Option number 1 is incorrect. P can be reduced to primary alcohol using sodium boron. Here, in P, we are not having any nitrogen. Nitrogen is not present. How can we get primary amine from this one? Upon reduction, we can't get any nitrogen containing compound. Primary amine can't be obtained, so that we can't say A is correct. Then go with B. Treating P with concentrated ammonium hydroxide followed by acidification gives a Q. So there is another way we said no. So whenever this alpha bromoacetic acid, propionic acid treated with ammonium hydroxide, simply bromo can be replaced with NH2. And here carboxylic acid also got neutralization, like ammonium salt, ammonium carboxylate will be generated. Okay, so this further hydrolysis, if we are hydrolyzing this one, amide linkage can be converted into what? Carboxylic acid. So this is another way to generate Q. Q is again alpha amino acid called alanine only. So that it is correct one only, option B. Option C, treating Q with a solution of sodium nitrate aqueous HCl liberates nitrogen. So this is a kind of reaction in NO2 HCl generates what nitrous acid will be generated that used to shift this NH2 with the OH. Right, so NH2 can be replaced with OH in the presence of this reagent NaNO2 and HCl, sodium nitrate and hydrochloric acid. So we will get alpha hydroxypropionic acid and liberating nitrogen gas. From this one nitrogen, so that nitrogen gas evolved. Whatever they are saying, absolutely correct. Okay, so this is the way. So in general, this mechanism is used for the synthesis of primary amines. So this potassium thalamide is everybody aware that potassium thalamide is more selective for the synthesis of primary amines. Primary amines can be synthesized. Okay, there are series of reactions where B, C, and D. So we have to go with the explanation for D as well. So in D, what they are saying, P is more acidic than acetic acid. We are comparing the acidic nature of this propionic acid and alpha bromopropionic acid. First of all, we have to see carboxylic acid acidic. Why carboxylic acid is acidic? In that name only we are saying carboxylic acid it is. Okay, why? It able to release H plus. So the species generate H plus is called acidic, but organic carboxylic acids are somewhat mild when compared to mineral acid like hydrochloric acid, sulfuric acid, nitric acid, like that. Because there is a possibility of covalent bond. In order to remove the H plus, it is somewhat difficult. Slightly they able to generate, so that we can say organic carboxylic acids are mild acids. But what we are doing, we are comparing propionic acid with the bromopropionic acid. Whenever bromo is there, what is the nature of bromo? Bromo is having strong tendency to pull the electrons, that is called minus I effect. Inductive effect towards the bromine will be there. It abstract the electron density towards that one. Whenever electron density dragged, what happens? This carbon is experiencing less electron density, so that it will strongly attract the electrons towards the carbon atom. Whatever electrons are there in between O and H, electrons are strongly pulled towards the carbon. Hydrogen freely liberated out. So that is mainly because of what? Minus I effect, inductive effect of the bromine. Bromine will strongly pull the electrons because of minus I effect, so that carbon will gain the electrons very strongly from the OH bond. Whenever electrons are strongly pulled, H plus easily liberated out. That's the reason why always alpha halo carboxylic acid is more acidic in comparison with the plain carboxylic acid. So this is justifiable for option number D. B is clear, C is clear, D is also clear, A is incorrect. Okay, so this is the way we can answer question number 4. For question number 4, B, C, D are the correct answers. Move on to question number 5. This is the question collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. How many microstates are possible for D5 electronic configuration? It is the question given from inorganic chemistry, microstates. Right, D5 system is provided to you. How many microstates are possible for this system? We need to assign. Okay, among all the options, option 4 is the correct answer. That is 252 possible microstates are there for D5 electronic configuration. We will see how can we explain this. For that purpose, there is a microstate table is there. For D1 electron, 10 are possible, D2 45, D3 120, D4 210, D5 252, D6 210, D7 120, D8 45, D9 10, D10 1. This is the way we can make a table for electronic configuration possible microstates. Okay, if you observe, gradually microstates are increasing up to D5, and there is a sudden decline, not sudden, a gradual decline in the what microstate values are possible from D6 to D10. Okay, so in order to calculate these microstate values, we have two possible formulas. Microstates can be calculated either by 2 into L plus 1, 2s plus 1. So this is one kind of representation, and another one will be 10 factorial by 10 minus n factorial into n factorial. So I think this is most simple to calculate the number of microstates. That's the reason why I opted 10 factorial by 10 minus n factorial formula. According to that, 10 factorial as such I wrote, and in the denominator I have 10 and n. N is nothing but number of electrons resided on the d orbital. In our problem, they are saying D5 system, no? That's why here n value will become 5. 10 minus 5 factorial, and again we have to put one more n factorial, so that 5 factorial will be there. What does 10 factorial means? 10 factorial can be expanded as 10 into 9 into 8 into 7 into 6, 5, 4, 3, 2, 1. This is the way we can expand. 10 minus 5 factorial. 10 minus 5, 5 itself. 5 factorial can be written as 5 into 4 into 3 into 2 into 1. And another 5 factorial is there, 5 into 4 into 3 into 2 into 1. This is the way we can expand the formula. Whatever 5 into 4 into 3 into 1 is there, they can compensate 5, 4, 3, 2, 1 in the numerator. Numerator, denominator, similar terms we can compensate. Whatever left over, 10 into 9 into 8, 7, 6 upon 5 into 4, 3, 2, 1 can be written, right? So after the multiplication, we can write like this, and finally we can calculate as a 252. For D5 system, number of possible microstates are 252. This is the way we can calculate whatever given in the table, exactly mapping. So for question number 5, option number 4 will be the correct answer. Move on to question number 6. This will be the last question of the session. How many spinalode electronic transitions are possible for the complex nickel hexamine plus 2 ion? Right? It is the kind of octahedral complex of nickel where nickel NH3 taken 6 plus 2 cation is there. Spinalode electronic transitions we need to calculate. Okay, these are 3. Okay, so in order to explain this one, first of all, we have to see electronic configuration. Nickel existing in this nickel NH3 taken 6 plus 2, nickel existing in plus 2 oxidation state are on the central metal, so that we can write like this. Okay, so N is2 4s2 3d8. So d8 system it will be. So if nickel plus 2 you're writing, so the 2 s electrons can be excluded. We need to remove these 2 s electrons, and leftover will be d8 only, right? So if you count 1, 2, 3, 4, 5, 6, 7, 8 electrons will be there. So if 8 electrons are there, it should generate octahedral complex, no? Being 6 coordination number, so that we need to give octahedral geometry. So here, if you see 4s orbital, 4p orbital, and 3d2 orbitals get combined by the hybridization mixing. sp3d2 hybridization, you get sp3d2 corresponding octahedral geometry. This is the way its electronic configuration, and sp3d2 hybridization is there. But our question is, how many possible spin-load transitions are there? In order to get that one, we are seeing its orgel diagram. In this orgel diagram, so it is somewhat complicated, I can say. And here the transition, if you observe 3A to G. So this is a short, this is the short arrow you can notice. 3A to G line to 3A to G. So here 3A to G is there. Here also 3A to G is there. So from here to here, if electrons are excited, this is said to be what? So it should be written as a 3T to G. There is a kind of spell mistake, because here if you observe this, you can clearly understand 3A to G can be excited to 3T to G. So this is the way we need to write. Actually, there is a we need to make a correction. Sorry for that. Okay, that is all. That is said to be what? Allowed transition. And one more will be, so if electron is moving from 3A to G into 3A1G, so 3A to G to 3A1G, if it is moving, that is said to be allowed again. So 3A to G to 3T1G is also allowed again. Okay, and one more will be there, 3A to G to 3T1G is there. So this is another arrow if you see, but it is said to be spin forbidden. We can't make a number to this spin load. So it is not the part of this one, right? And if you observe this one, 3A to G, 1EG. This is another kind of a transition which is favorable for spin load transition. So possible spin load transitions for this nickel hexamine dication will be taken as, one is 3A to G to 3T to G, 3A to G to 3T1G, 3A to G to 1EG. This is the way we can answer. By this, three possible spin load transitions are there. For question number 6, option number 1 will be the correct answer. I hope this session will be very much helpful and it is understandable. Everything is very clear, I hope. Hence, I am sincerely requesting you to kindly like the channel and comment which part is really interesting for you, and share with the aspirants who are seriously preparing for any competitive exams or else entrance examinations, and subscribe the channel in order to get more updates regarding the same content in the near future. Thank you very much for your patient listening. Thank you one and all.